If you've worked on motorcycles for any length of time, you've probably serviced carburetors with contaminated fuel jets. Jets that became clogged because someone stored the cycle without preparing the fuel system. That's why we've brought you to Honda's Training Center to explain how improper vehicle preparation can lead to fuel jet contamination and to show you how to prevent it. Now, you'll get more out of this program if you've already seen the full cycle video, Carburation Equals Air Plus Fuel, which explains basic carburation theory. In this program, I'll show you how to identify the types of drivability complaints that are typical of contaminated carburetor fuel jets. I'll describe the steps you can take while preparing the motorcycle to prevent some common types of fuel jet contamination. I'll show how to synchronize multi-carb sets and demonstrate how to adjust the pilot screws for the best idle and low-speed performance. Every spring, service departments are flooded with motorcycles that are brought in for their spring tune-up. Now, that's when customers dig out motorcycles they haven't ridden all winter and find that the cycle may not start or run well. Many times, the trouble is caused by deposits that have formed in the carburetor fuel jets because the owner stored the cycle with fuel in the carburetor. Now, you may remember from Carburation Equals Air Plus Fuel that gasoline is a mixture of chemicals blended to control how the fuel vaporizes and burns. The more volatile chemicals in gasoline can evaporate when the fuel is being stored, leaving less volatile chemicals to become more concentrated in the remaining gas. When these concentrated chemicals react with oxygen, they thicken to form gum. If this gum gets into the carburetor fuel jets, it can reduce or even stop the flow of fuel into the engine. The residue you sometimes find in carburetor float bowls is gum. Fuel will begin to deteriorate and form gum if it's left in the motorcycle for more than a month or so. That's important to remember when you're diagnosing drivability complaints, especially on a motorcycle that hasn't been ridden for a while. When you're diagnosing a complaint, you should start by interviewing the customer and recording the symptoms on a performance questionnaire. Now, I filled out this questionnaire to show the symptoms that can be caused by contaminated fuel jets. The symptoms include surging at idle and low throttle settings, but only when the engine is hot. The engine also stumbles under acceleration from low speeds, and the engine is difficult to start when it's hot. Surging and stumbling are symptoms of fuel starvation. The engine surges at idle and low RPM, times when the throttle openings are small. But there's no problem at mid and high throttle. So we know that it's not a general lack of fuel, such as a clogged fuel filter. This indicates that the carburetor's low-speed circuit isn't functioning properly. The owner reports stumbling when he accelerates from low speeds, but only when the engine is hot. The engine runs well cold, which is usually when the choke is on, and the stumbling only occurs when the engine is hot, after the choke has been turned off. Since the engine runs well as long as the choke is providing extra fuel, the poor performance is probably due to a lack of fuel from the low-speed circuit. The engine is hard to start when hot because the rider doesn't use the choke when the engine is hot. This also indicates a lack of fuel from the low-speed circuit. You can test for a malfunctioning low-speed circuit by trying to start the hot engine with and without the choke. Now, if it only starts when the choke is on, you know the low-speed circuit isn't supplying enough fuel. Now look at the questions section. The motorcycle was last stored when the weather turned cold in November and was stored for 3 months, till the weather got warm again. If the motorcycle still had fuel in its carburetor when it was put into storage, there's a good chance that the low-speed fuel jets are contaminated with gum deposits. The fuel jets of the low-speed circuit are the smallest jets in the carburetor, so they're the most easily clogged by any deposits in the carburetor. Even a minor buildup of deposits in the low-speed jets can reduce fuel flow at low speed, or stop it completely. When you know that customers won't be riding for a month or more, suggest that they prepare their motorcycles for long-term storage, following the storage procedures listed in the storage guide section of the owner's manual. I'll demonstrate how to prepare the fuel system on this single-cylinder GB500. Now, it's a good idea to run the tank down to reserve before draining the fuel system, so there won't be a lot of hazardous fuel left to drain.
Switch the fuel valve to off and disconnect the fuel hose from the tank valve. Push a drain hose onto the fitting and put the other end into an approved fuel container. Open the valve to empty the tank, then reconnect the fuel hose to the tank valve and spray the inside of the tank with Honda multipurpose lube to prevent corrosion.
Next, we'll drain the carburetor float bowl. The cycle should be on its center stand or held upright to allow the bowl to drain completely.
If the motorcycle doesn't already have one, push one end of a hose onto the fitting at the bottom of the float bowl and put the other end into the container. Loosen the screw at least a half turn then retighten the screw after the fuel has finished draining.
Repeat the procedure on each carburetor of a multi-cylinder motorcycle. When the float bowls are empty, crank the engine several times to clear any fuel held in the jets. Even the GL 1500 has carburetor drain screws.
They're accessible through these holes at the center of the radiator grill. Connect an extension hose from the drain hose, here, below the right peg, and run it into an approved fuel container. Carefully probe for the drain screws with a long, flat blade screwdriver. Open each screw a half turn and close them when the bowls are empty.
The storage procedures for the motorcycle's other systems are described in the owner's manual. Technicians have had some awkward moments with customers who bring back their new motorcycles the very same day they bought them. Even a new motorcycle's low-speed fuel jets can be clogged by gum deposits, left by aging fuel or by foreign material flushed from the fuel tank. These conditions and drivability complaints can be avoided by following the setup and pre-delivery service described in the Honda Care Delivery System Dealer's Guide. Maybe the carburetor fuel bowls weren't drained when the cycle was set up. Every Honda motorcycle is test run at the factory before it's shipped. Occasionally, a motorcycle arrives with a small amount of fuel still in the carburetor float bowls. Since aging fuel leaves deposits that can clog the fuel jets, it makes sense to drain the fuel system of each new motorcycle as part of the setup procedure. Check the tank and each float bowl for remaining fuel, as I demonstrated earlier. Then crank the engine a few times to clear out the jets. Dispose of the drained fuel properly. In most cases, you won't get any fuel, but when you do, you'll know you've prevented a potential drivability complaint. The second type of carburetor contamination only affects new motorcycles and usually occurs when a technician fails to follow the steps of the Honda Care delivery system. The inside of every fuel tank is sprayed with a coating at the factory to prevent this type of corrosion during shipping and storage.
The coating dissolves in gasoline. One full tank of gas will remove the coating from the tank walls and dilute it so it flows through the carburetor without redepositing in the jets. But if the motorcycle's first tank of gas isn't a full tank, that same amount of coating mixes with less gasoline and becomes more concentrated. This concentrated coating can deposit inside the fuel jets and cause the drivability complaints we've seen.
When you do get a carburetor that is restricted by gum or other contamination, you should remove the carb and disassemble it for a thorough cleaning. Remember to wear eye protection during the cleaning process, and to handle the carburetor cleaner as carefully as you'd handle gasoline. The deposits can usually be removed by spraying the jets with Honda carburetor cleaner and blowing out the jets and passages with air. In cases of severe contamination or corrosion, it may be more cost-effective to replace removable jets than to spend a lot of time cleaning them. Never try to remount a contaminated jet with a piece of wire or a drill. The tool can enlarge the jet and change the circuit's air-fuel ratio. Now, whenever one carburetor in a set is disassembled for cleaning, all of the carburetors must be synchronized and have their pilot screws adjusted. I'll demonstrate carburetor synchronization first, and then I'll show you how to adjust the pilot screws using the idle drop procedure.
Carburetor synchronization, or carb sync, is the process of adjusting the position of each carburetor's throttle plate at idle, so the same amount of air flows through each one.
You don't want one cylinder taking in enough air for cruising speed, while another cylinder is only getting enough air for idle. The factory synchronizes multi-carb sets by measuring the amount of air passing through the carburetor throats at various throttle settings. But synchronization can change over time due to wear in the carburetor linkages, which changes their alignment. Sync can also be affected by the condition of the piston rings and cylinders, and valve seats. Any wear in these parts can change the amount of air flowing through the carbs on each intake stroke. This is why carb sync is included in the routine maintenance schedule. Out-of-sync carburetors can cause various symptoms, including poor idle or other drivability complaints, stumbling or flat spots under acceleration, decreased fuel economy, or popping sounds in the mufflers or carburetors. In some cases, out-of-sync carburetors can even cause a hollow knocking sound during idle that can sound like a loose rod bearing or piston pin. Out-of-sync carburetors can also be caused by air leaks or other conditions that affect the flow of air through the carburetors. Look for a dirty, damaged, or non-standard air filter. Check the intake system for disconnected, damaged, or pinched hoses, and inspect the insulator rings, O-rings, or carb mounts for damage. Also check for improperly tightened clamps that could be causing air leaks below the carburetor. If the symptoms persist after you've checked all these possible causes, you can be pretty certain that the carbs need to be synced. I'll demonstrate the procedure on this XL600V Transalp. Other multi-cylinder engines may be different, so you should follow the procedures described in the service manual. Run or ride the motorcycle to normal operating temperature and set the idle to specifications. Then prepare the cycle following the procedures in the service manual. Calibrate the sync gauges before they're used, following the procedures described in the Special Tools newsletter, General number 40. One thing, make sure the gauge's damper valves are lightly seated before you start the engine to avoid damaging the gauges on startup. Run the engine at idle and crack open the valves until the needles respond. Then close the valves just enough to steady the needles. Adjust the idle with the throttle stop screw, snapping the throttle after each adjustment to settle the linkages. According to the service manual, the pressure readings for the cylinders shouldn't vary by more than 40 millimeters, about 1.6 inches of mercury. Even if the carburetors are within this range, it only takes a little effort to get them to match perfectly. On this engine, the base carburetor feeds the rear cylinder. Its throttle is set directly by the throttle stop screw. The front carburetor's throttle can be set independently, with the synchronization screw between the carburetors. The sync screw can usually be adjusted through this access hole with the air cleaner in place. If the front carburetor's reading is higher than the base carbs, you decrease it by turning the sync screw clockwise to open the front carb's throttle plate. Turning the sync screw the other way will close the front throttle plate and increase the front carb reading. Use the throttle stop screw to keep the idle speed within specs, and snap the throttle after each adjustment to settle the linkages. Remember, I told you that an out-of-sync carburetor can cause a knocking sound in the engine. Listen to this. When the carbs are out of sync, one cylinder is working harder than another, causing uneven loading of the valve train. You'd hear a similar sound if you disconnected one of the spark plugs. The last thing we'll do is go through pilot screw adjustment on multi-cylinder motorcycles. I'll show you how to adjust the pilot screws on a multi-cylinder engine using the idle drop procedure. It's called the idle drop procedure because you adjust the pilot screws while watching for changes in the engine's idle speed. The idle drop procedure allows you to set the carburetor's idle mixture for the smoothest idle and the best transition to mid-range operation without an expensive exhaust gas analyzer. For single-cylinder engines, the pilot screw adjustment is different, so you should follow the steps described in the appropriate service manual. You should synchronize multi-carb sets before you adjust the pilot screws. Carb sync can be affected by pilot screw adjustments, so it's a good idea to leave the sync gauges connected during the idle drop procedure. And watch for changes in carb sync as we set the pilot screws. We'll need a few things to do the idle drop procedure: an electronic tachometer that can show changes of 50 RPM or less, and aluminum plugs or caps for the pilot screws. The pilot screws on street cycles are factory set to meet emission regulations and fitted with different types of anti-tamper devices. They have to be removed to service or adjust the pilot screws, but new plugs or caps must be installed afterwards to satisfy state and federal regulations. So make sure you have replacement parts before you begin. There are 3 types of anti-tamper devices: flat plugs that must be drilled and removed with a screw, rounded plugs that come out with pliers, and limiter caps. Plug or cap removal can often be done with the carburetor in place, but sometimes you'll need to remove the carburetor to access the pilot screws. Follow the service manual instructions carefully to avoid damaging the carburetor or other components. In the idle drop procedure, we identify the overly rich and overly lean settings of the pilot screws in order to find the middle ground, where the engine is running on the ideal air-fuel ratio. This air-fuel mixture graph will show how the mixture varies between rich and lean as I make the adjustments. We first identify the rich end of the mixture scale. For this stage, the pilot screws must always be adjusted together. Gently seat the screws, then back them out to the setting listed in the service manual. Then run the engine to verify that the carburetors are still synchronized, making adjustments as needed. Connect the tachometer, run the engine, and set the idle speed to an exact number within the specified range. You want to keep the engine at the same speed throughout this procedure. Turn all the pilot screws out 1/2 turn to enrich the idle mixture. Then check the tachometer. If engine RPM rises, adjust it to the original speed. Continue backing out the pilot screws 1/2 turn at a time, adjusting for idle speed increases until idle speed drops by 50 RPM or less. Readjust the idle with the throttle stop screw. The carbs are now running rich. The next step is to find the lean end of the mixture scale. For this, you adjust each of the pilot screws individually. On this engine, we first adjust the rear cylinder idle mixture. Gradually turn the pilot screw in, giving the engine time to react between adjustments, until engine speed drops 50 RPM. Then turn it out 1 turn to get the ideal air-fuel mixture. Readjust the idle speed and adjust the remaining carburetors following the same steps. Check the gauges for changes in carb sync and resync the carburetors if necessary. Stop the engine, disconnect the gauges, install the new plugs or limiter caps according to the service manual's instructions, and finish the assembly. Well, that's it. I've explained some of the drivability conditions that can result from fuel jet contamination. I've explained how to prevent contamination, and I've taken you through carburetor synchronization and shown you how to use the idle drop procedure to adjust the pilot screws. Customers are extra sensitive to the way their new vehicles perform. So when you take the time to set up and store a motorcycle properly and give it a thorough pre-delivery service, you'll be preventing carburetor contamination and reducing drivability complaints.